Now this lecture is about Cayley Hamilton Theorem. This is very important topic for this chapter, and this topic is easy, don't need to worry. So the statement is that every square matrix satisfies the characteristic equation. As I have told what a characteristic equation is, so this statement means that whatever the characteristic equation which we get, every square matrix satisfies that characteristic equation. You will get through one example, wait. And you note down this formula for 2 cross 2 matrix, lambda square minus trace of A into lambda plus determinant of A, and for 3 cross 3 equals to 0, and for 3 cross 3 matrix this is the formula. Okay, trace, you know the sum of diagonal element. So and C11, C22, C33 are corresponding cofactors. You know how to find cofactor, you have learned in your lower classes. So just note down these two formula. Now I'll explain Cayley Hamilton through example. Let us suppose A is a 3 cross 3 matrix, okay, and we need to find A inverse. So how to find A inverse for the provided matrix? Don't do the thing which we have learned in our lower classes, that simply finding adjoint of A, determinant of A, all those stuff. We'll do like this: A minus lambda equals to 0. Okay, that is, we are going to find the characteristic equation. Putting this value, we get this determinant. Solving the determinant, we get this equation: lambda cube minus 6 lambda square plus 6 lambda minus 11 equals to 0. This is your characteristic equation. And according to Cayley Hamilton theorem, we know that the square matrix satisfies this characteristic equation. So according to Cayley Hamilton, we will put A in place of lambda. Just in place of lambda, everywhere where there is a lambda, just substitute A. Okay. After substituting, you will get A cube minus 6A square plus 6A minus 11I equals to 0. Now multiply A inverse on both the sides. You will land up to A square minus 6A plus 6I minus 11A inverse. You know I into A inverse is A inverse, and A into A inverse is identity matrix. You know this stuff, right? Equals to 0. Now transfer everything to RHS side. Just keep A inverse to LHS side, because we have to find this only. Now we have A matrix, we know identity matrix, we just need to find A square. It's simple, just multiply, you know the multiplication of two matrices. You will get A square as this. Just substitute this value into this equation. You will get A inverse as 1 by 11, 5 minus 1 minus 7 minus 4, 3, 10, 3 minus 5 minus 2. And this satisfies your Cayley Hamilton theorem, and this is how you find A inverse. So I'll show another example. I got one exercise question for you. We need to find A inverse of this given matrix. I'm giving you the answer. Note down the answer and just match if you get the same answer or not. Okay, so this is problem for you. You need to do this. Follow the same process as I have taught you earlier. So now we will see the next type of question which can come for Cayley Hamilton. Okay, so using Cayley Hamilton theorem, find the equation is given. We need to find this. This seems complicated, right? But it's not. Okay, let's see how to proceed. And your A matrix is this. So again the same thing, A minus lambda equals to 0. You will get this, and solving the determinant, you will get lambda cube minus 5 lambda square plus 7 lambda minus 3 equals to 0 as your characteristic equation. Okay, now by Cayley Hamilton theorem, you can substitute in place of lambda, you can substitute A. You get A cube minus 5A square plus 7A minus 3I equals to 0. Now just write down the given equation, whatever the equation was given to find the value. Just write down that. You will find that we can take out something common and just try to, our approach is just to try reduce this equation such that we get this whole term. What is this whole term? Why we need to reduce in this format? Just because this whole thing which we have got through characteristic equation is 0. So if we get to reduce this equation in terms of this thing, we can easily substitute 0 here and it's easy for us to find. So I will take a to the power 5 common from this side, and a to the power 8 was there, so you will get a to the power 3, then minus 5a square plus 7a minus 3i. Okay, plus now take a common from this side, okay, the left thing, this thing. You will get a cube minus 5a square plus 3a minus 2i plus I equals to 0. So this thing is the same equation, you know that's equal to 0. So this term is cancelled out. Okay, we will be left with a cube minus 5a square plus 7a minus 3i, this term. Now our aim to reduce this term also in terms of this, so that we can easily substitute 0. So what I have done is that I have just simply written a cube minus 5a square, and this 3a I have to get 7a, so I just wrote 7a. Okay, and then I have to get 3i, so I wrote 3i. Now whatever I get extra, like I got this extra, my bad, this is 8, it was not 3. So now whatever is the extra, like there is 7a and we need to match this, so we need to add plus a, and here it is minus 3i. Okay, following this, but here it is minus 2i, so we will add 1i, and what more changes we require. So yeah, we have reduced this to this. Now just simply, this term is also gone, we simply get a square plus a plus I equals to 0. Now just do one thing, find a square, find a is given, I is given, just simply add, you get this. So this matrix is the value for the given equation. So this is how you do.